Alright guys, we got our 8.2 lesson with Pythagorean theorem and its converse. Pythagorean theorem is not new to you. We're looking at the longest side here for C, which is our hypotenuse. We square our two legs, and there should add to equal the square of the longest side here. We are switching the formula around. You'll see why. We now want to get used to seeing C squared equals A squared plus B squared. So on number 1, you're going to do this on your own. All right, because we're just looking for C. Remembering that X is across from our right angle, giving us our longest side, just like right here. So you guys are going to use your C squared equals A squared plus B squared to figure out what the length of the hypotenuse is. Solve for X. All right, moving on to B. I'm going to go ahead. Obviously, we got some radicals here. No big deal, though. We're used to this. So I'm going to find my C right here. So using C first, I'm going to take the 6 square root of 2 squared is equal to, now A and B, it doesn't matter which one is which. I like my variable first, so I'll say x squared plus 36 squared. Do not forget about your squares. Now, when we square the 6 square root of 2, we remember that we're going to square that first number, the whole number, 36, and we're going to multiply it by that radicand of 2. All right, and I'm just going to kind of go baby step by baby step. Here, sorry, this should be 6. Sorry about that, I already gave you the answer there. 6 squared of 36. Over here, we're going to multiply the 2. 36 times 2 is going to give me 72 equals x squared plus 36. Now I go through our little steps, subtract 36 from both sides. 72 minus 36, we're going to end up with 36 equals x squared. Do not forget that we have to find the square roots of this, okay? So luckily in this case, these cancel out. This came out to a perfect square, so x is going to equal 6. So we actually find out that we have an isosceles triangle here. C, I'm going to do a little bit of work for you, and then you're going to solve the remainder of it on your own. Okay? Here we're going to talk about a few things. We need a right triangle. Where's my right triangle? Hey, look. Let's draw a line here. Now we have a right triangle over here. So I'm going to redraw my right triangle. Here's my 90-degree angle. Across is going to be that x. So we have to figure out these two legs because we know we're looking for the hypotenuse here. So, right here I have a rectangle. How do I know? Because I've got 90-degree angles. We'll learn more about quadrilaterals later. So with rectangles, we learned that the sides across from each other are the same. So from here to here is going to be 5, leaving us, 11's the whole thing, leaving us with 6 left over to be this leg right here. So this will be 6. Your other pair of sides will also be congruent, giving us our other leg of 8. This is where I'm going to leave you to solve on your own. Okay? Now let's take a look at D. We have here a right triangle. We've got a square. We know because we have 4 congruent sides. But let's take a look at this right here. Here we have x as the side, which means all 4 sides are going to be x. So when we have our separate triangle, we find out that our hypotenuse is 5 square root of 2. We need to figure out what the 2 legs are. So still using our c squared equals a squared plus b squared. C is going to be 5 square root of 2 all squared equal to, well, a and b are both x. So we have x squared plus x squared. Bringing this down, we're going to go ahead. We're going to see here we have, remember that we're squaring the whole number with a radical. We're going to square the whole number to 25, and then we just get rid of that. We have it times 2. We're going to multiply it by that radicand. On the other side, I have 2x squared. It's just like saying you have 2 x's. You're going to combine them to 2x squared. Exactly what I just said, in fact. Now, before I even go multiply over here, I can see that I could divide this by 2, and these 2 are going to cancel out. So then all I have is x squared equals 25. I'm going to take my square root of both sides to cancel the square. And we're going to get another nice, pretty perfect square. X will equal 5. Okay? Next, common Pythagorean theorem triples. These are very, very good to know. So that way you can recognize a right triangle right away. You've got your 3, 4, 5 and the multiples of them. You got your 5, 12, 13, the multiples. 8, 15, 17, the multiples, and 7, 12, and 25. So these are your common triples. So what I mean by the multiples is 6, 8, 10 is a 3, 4, 5 times 2. 9, 12, 15 is a 3, 4, 5 times 3. And so on and so forth. Same thing with all of these. Okay? We're going to talk about the converse of the Pythagorean theorem. Instead of actually sitting there trying to figure out what a missing side is, we need to figure out, is it going to be a right triangle? So here we're told that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, that a squared plus b squared, then you have a right triangle. So there's that c squared. So if c squared equals a squared plus b squared, then you have a right triangle. I'm going to do the first one for you. You're going to do the second one by yourself. All right? I believe in you. Now, I do have to draw them in right angles for you guys because I did not, but here are your right angles on both of these. So how this sets up now is we have our formula c squared equals a squared plus b squared. We're going to plug in all three numbers and see if it comes out equal. First thing here, c. So we're going to have the square root of 113 squared is equal to, again, doesn't matter which one's a and which one's b. So I'll go 8 squared plus 7 squared. Remember, when we're squaring just a radical, these cancel out, leaving us with 113 equals 8 squared is 64 plus 7 squared is 49. I am running off the screen, sorry there. Now I'm going to combine these and to see, does it equal 113? Well, in this case, 64 plus 49 is going to equal 113. So I could check it off the list, and I could say, yes, we have a right triangle. So you're going to do the same thing for letter B. Exact same process, noting where your C, where your hypotenuse is, and figure out if you've got a right triangle or not. All right, last page, we're almost there. Now we're going to talk about our inequalities, all right? Going back to some inequalities, the Pythagorean theorem, inequality theorem. Now we're going to be able to determine where, for any triangle ABC, where C is the length of the longest side, okay, just like we normally do with Pythagorean theorem, but right now we're looking at, okay, it's just a triangle. Not saying anything about a right triangle yet. If C is the length of the longest side, then the following is true. If you plug in c squared just like we did earlier and you find out c squared is less than a squared plus b squared, then you have an acute triangle. Less than a squared plus b squared, less than 90-degree acute. Okay, that's why we're setting our equations up like this now. But if c squared ends up greater than a squared plus b squared, then you have an obtuse triangle. So the first thing we need to do is actually figure out, hey, we learned how to determine if we have a triangle or not. So we need to go first find out, do we have a triangle? First thing, all right? So here's our biggest side. We need to remember that if we add our two smaller sides, it has to be greater than that third side in order for it to be a triangle. On this problem, 5 plus 4 gives me 9. Hey, that is not greater than. Therefore, we don't even have a triangle. So we don't have to move on. We're done. Woo! Yay! So with I'm going to do C since we have some radicals, but B, you need to do the exact same thing. First things first. Find out. And then after you guys see me do C, you'll see filling in the formulas and whatnot and working that out, and you can go back and work on it. Here, we first have this radical, and we need to determine if the radical, what the number is approximate, so I know which one's my biggest side. So the square root of 10 is approximately 3.16, meaning this is our bigger side. So first, let's find out, do we have a triangle? We'll take our first two our smaller sides. 1 plus 3, is it greater than 3.16? Well, that ends up being 4. Is 4 greater than 3.16? Yes. So now we can go ahead and move forward with our formula. Let's go ahead and take a look. We're going to be looking at seeing if c squared is going to be, and I usually put a circle here to fill in greater than, equal to, greater than, less than, or equal to. And I'm going to have on my other side the a squared plus b squared. So now let's fill in. C squared was going to be that square root of 10. That was our biggest side. So the square root of 10 squared is something to a squared and b squared. Doesn't matter which one's which. So 1 squared plus 3 squared. Here these cancel, and I'm given 10 will be greater than, less than, or equal to 1 plus 9. And what ends up happening here is these end up being equal. So we actually, this does not follow the greater than or the less than. This ends up being equal to, so therefore we can conclude we have a right triangle. Okay? You will do D on your own as well. I will give you a hint. Both B and D will not be right triangles. So you're either going to be following, if you find out that the C over here, you end up with a less than sign, so the number on the left is smaller than the number on the right, you're going to have an acute triangle. If you find out the number on the left, c squared, ends up being bigger than that a squared plus b squared over here, so the greater than, you're going to have an obtuse triangle.